Welcome to Summarize Science. Have you ever thought about how we train an AI? Traditionally, it's like baking in an oven. You set all the parameters, close the door, and just wait for it to finish. But a new paper introduces a revolutionary idea. What if we could train AI like we're cooking on a stove, with the ability to make adjustments in real time? This concept is called interactive training, and this is the dashboard that makes it possible. It's a user interface that allows a person to monitor all the important training metrics, like loss and performance, as they happen. But unlike normal monitoring tools, this one is a two-way street. Notice the control panels on the left. These allow a user to send commands directly into the live training process to change things like the learning rate instantly. The whole system is built around a central control server that acts as a middleman. It takes commands from the user on the dashboard and relays them to the AI that's actively training. Simultaneously, it gets status updates from the training process and sends them back to be visualized on the dashboard. So, does this hands-on approach actually work better? In their first case study, the researchers had a human expert use the system to fine-tune a language model. The expert watched the model's performance and dynamically adjusted the learning rate whenever things looked unstable. As you can see from these graphs, the interactive human-in-the-loop method achieved a much better final result compared to the static, preset method. But here's where it gets even more interesting. What if you could replace the human expert with another AI? That's exactly what they did in the next experiment, where they intentionally started the training with bad settings that would normally cause it to fail. They fed the training logs to a large language model and asked it to decide whether to increase, decrease, or keep the learning rate the same. Amazingly, the AI agent successfully diagnosed the problem and corrected the learning rate, saving the training run from failure. Finally, they showed how this can be used to adapt a model to real-world data on the fly. They took a model designed to simulate a computer's operating system and fed it new data collected from real users. Before the interactive updates, the model consistently failed at simple tasks like opening the Firefox browser. But after being fine-tuned with new, real user data in real time, the model learned to successfully complete the task. So, let's recap the important points. This research transforms AI training from a static, passive process into an active, responsive one. It's the difference between setting an oven timer and actively cooking on a stove. The framework allows for real-time intervention and fixes, guided by either human experts or automated AI agents. This could mean the future of AI development is far more efficient, with AI agents autonomously monitoring, debugging, and optimizing each other's training. Instead of just waiting for results, developers can now have a direct conversation with the training process itself. Thank you for watching this episode of Summarize Science.